Today we're going to look at a new autocoder in which we enter a simple original instructions, and rest of the time GPT-4 keeps instructing and giving feedback to Opus, and it's an iterative and automated process. And actually working together, GPT-4 and Claude can create very complex apps. We can also turn on user guided mode and add additional instructions every step of every turn as well. We're going to take a look at several examples that I've created, but before we do that, we can actually run this and give it some instructions and have it working while we are reviewing some of the older projects I've created. Let's go for a checkers game and pie game using all the in-game assets. And while this is ongoing, first Opus is going to write the code, then GPT-4 is going to come in and review it and provide feedback, and this will go on as currently set up for 3 iterations. I'm going to go ahead and create a split terminal here and actually give it run this code again, but this time let's turn it into an HTML, and let's run this again and give it just a basic, like, interesting HTML canvas animation, or actually let's ask for a simple HTML canvas game. I did change the file extension because we're going to be saving the files here. This is a Python file, and this one is going to actually save it to HTML file. Anyway, so this is like the first iteration. As you can see, it's 63 lines of code, and in the second iteration is 66 lines of code. Let's see where this goes. Maybe we can also increase the iteration level as well. Now, while this is ongoing, let me show you some of the projects I built here. I actually instructed it to replicate Apollo 13 mission in HTML canvas. This was the first file. As you can see, it was the first time around, it wrote 230 lines of code. And by the time we finished iterating, it was 340 lines of code almost. And if I actually start this HTML animation using the live preview extension, you can see that this is what it created, and I can actually play it, and it'll show the trajectory of the spacecraft along with what happened during the mission with annotations updating. I can actually reverse it as well, fast forward in reverse direction. I can reset it and play it and fast forward it. As you can see there. So this is pretty incredible. I mean, obviously the trajectory of the spacecraft is not like this, but I was very surprised the fact that it did it. And you can actually adjust the speed here as well, I believe. If we increase it, it just plays it speedily. So this was a very good one. So this took about 4 iterations, and here's a HTML canvas animation I was able to create with this, which is really cool. This was entirely automated. I only asked for an HTML canvas animation. As you can see, there's a little circle here that repels these animations. And if we left click, we are adding particles. I don't know if you're able to see, but it's added in a random spot, and we right click, we can slowly remove the particles. Code files for this autocoder will be available at my Patreon at the architect level. Link will be in the description. We will be reviewing the code after we take a look at some of these examples. Also, we are done with our iteration on the checkers game, and it actually increased to 100, almost 90 lines of code from 63. Let's go ahead and try it. So I just ran it. Let's see if it actually was able to. Oh, okay. There we go. It did create the checkerboard, although I'm not able to move anything just yet. Maybe I have to do something. Now the cool thing is actually we can copy this latest code, paste it into working-file.py, and go back to our autocoder and change this to .py again, because it'll actually check for this working file. You can go ahead and delete these .py files. And if I were to run this again and ask it for a checkers game, as I did before, it should actually continue iterating from this. So let's go ahead and do it. And our HTML animation is also done. I think we asked for a game. The first iteration was 100 lines of code, and the third iteration is 150. Let's go ahead and take a look at what this looks like. So this was entirely automated, this GPT-4 interacting with Opus. There we go. Oh, we created base parts. Okay, we created this game. I forgot what this game was called, but yeah. So just entirely on its own. Let's go ahead and take a look at what the first iteration looked like. It's coming up. Yeah, okay. Even the first iteration worked, but it didn't have the spacebar to reset. So GPT-4 actually keeps recommending stuff for Opus to add. So that's really nice. We can actually copy the latest version of our code, paste it back into the original file, change this to HTML, and actually continue from where this is left off by running it again, just as we did, and giving it the same prompt. Let's see where it takes us. Canvas skin, let's see. If you're enjoying my videos, you can find all 250 free coding videos I've created, both at my YouTube channel and at my website, echohive.live. This project do use the Opus Claude Unified class and OpenAI Unified, and you can actually watch more in detail about this in this video. And also, I built many other projects using that. And if you wanted to dive deeper into the Claude Unified, you can watch the Easy Opus Autocoder. And if you are a patron, you can find the code download files for all of this, including the super fast two-way Opus voice chat with WebSockets. As a patron, you will have access to over 200 interesting and unique project code files. Okay, it looks like we have, let me look at it from VS Code. It looks like we have completed our iterations, and now our checkers game have almost 200 lines of code. Let's run this one and see what it looks like. Okay, the second file had the error, although it's not obvious here. It used a capitalized attribute, which doesn't exist, but I ran the one iteration before then, and actually we are now able to play the game just as like that, and before we couldn't. So this functionality was added just by running it for 2 more iterations. And now I believe we added a score card for the HTML canvas game. We can actually take a look at how we can take control and provide instructions at every turn as well. But before we do that, let me show you a few more. This WikiDB app that I built only in 2 iterations. We was able to build this app where we give it a topic, and it tries to find up to 5 Wikipedia articles and saves them to a SQLite database. Let me go ahead and run it, and you can see this was, again, entirely automated. It asks for a query. Let's go ahead and type in books, and it searches for a book and should have created a database. I'm going to open it with the SQLite Viewer extension that you can install. It's continuing to save them. As you can see now, we are saving each entry along with its summary and the URL, which we can go and visit. It checks up to 5 books, and let's search for AI. And if it actually cannot find an article, it stops right there. Now, if we refresh, you can see we got artificial intelligence, and if we run into some kind of error, it stops right there, but allows you to continue. For example, let's say stock market. And it'll continue to add to our database. As long as it can find articles, they will be added to the database. So it's a neat little app, and it was entirely generated with collaboration between GPT-4 and Opus. Like I said, the code files for this project will be available at Patreon. All you need is your Claude and OpenAI API key, and you can start using it. One last thing before I move on. What I found out is that actually, over many iterations, I don't think I have it here, but Opus is able to generate up to 400 lines of code with almost without errors, and about 7 to 8 out of 10 times it actually works. And then right around the 400 line mark, it starts returning incomplete code. So just keep that in mind. If you do run it for 50 generations or something, you might actually end up getting unfinished code. But it's incredible that it can return up to 400 lines of code, like with very minimal errors. And almost always the code is in running condition. So I wanted to do an experiment, and actually I ran Haiku. I asked Haiku model, which is the smallest of the Claude models, Claude 3 models. And I ran it for 50 generations, and it was able to generate error-free code of up to 230 lines. And it kind of couldn't go beyond that, but at least it was error-free. And actually, when we run it, we do see that we do have a working tower defense game. It doesn't work very well, but at least we are shooting projectiles. And in some of these examples, if we run different versions, we are actually keeping track of scores and whatnot. Let me run this 35th version. But Haiku was unable to go beyond 230 lines of code, but nevertheless, these are exactly as it was generated from Haiku. So it's actually, this particular one actually almost crashed my computer. But yeah, I mean, the point is, all of these are written straight from Haiku with no errors, and they're up to 230 lines of code. I haven't tested it with Sonnet, but I'm expecting that should perform very well as well. So before we talk about the code, we can run this in user-guided mode. Let's try that. Again, you can enter your file here. I'm going to keep working file, and I'm going to change into a Python file. And I'm going to delete all these files except the working file.py, because I'd like to start with this WikiDB, the final version of the WikiDB. I'm just going to go ahead and paste it into working file.py. We could have started from scratch just as we did with the automatic iterations, but as you see, as we saw, this WikiDB program, if it encounters any errors, then it doesn't save all 5 of the search results, and it actually performs only 5. I'm going to try to add additional instructions, and I'm trying to get it to save 5 articles at each turn, even if it encounters errors. Anyway, that's what we're going to try to do. So how we work in the user-guided mode is that I have this additional instructions.txt. At each turn, actually, this GPT-4 Opus autocoder checks if there's a working file, and it actually loads that file into its context and also checks for additional instructions, both in the beginning and at each turn. Instead of entering the user input directly from the terminal, I thought this is a more flexible approach because you can actually enter many hundreds of lines of instructions or even present code examples here. So I'm going to go ahead and write an instruction. So I'm going to ask for this instruction. In this current form, if we encounter an error from Wikisearch, we stop saving to DB and go back to taking query from the user, but we would like to continue the search from where we left off and save articles until we have saved 5 for each turn. Now I'm going to go ahead and run this. And since the beginning of this turn, I'm going to say, please improve this app. Improve this app based on instructions, because I have already entered the instructions and additional instructions. And it will first write it out, and then it clears the instructions, and I can actually copy this. Once it reads the instructions, it clears it, but we can actually enter it again. Well, let's see what it does now. It should overwrite the working file. Let's see. Okay, we did actually improve it. We do now have a saved count, and if we haven't saved more as much as 5, we now could not save 5 articles. So I'm going to paste in this instruction here again so you can see what's going on. After the first iteration, now it asks us to please provide instructions and additional instructions.txt, and I press enter. Additional instructions will be read from this file. This instruction is actually going to be read by GPT-4 first and going to get reinterpreted. So this is the instructions that GPT-4 is generating for us. As you can see, it actually possibly says it better than we can describe it. And it also offers other improvements. It's actually instructed to offer up to 5 improvements. So let's see what it does. Now Opus is actually following GPT-4's instructions, and we should get a working file _1.py after this iteration. And as you can see, the additional instructions are cleared. Now this is the new code that we get. Let's see. So when we actually run this, I ran it with artificial intelligence. This time it creates a much more robust data structure, including with summary, URL, title, last access date, and is read. And when it encounters non-existent page, it skips it. And if we actually look at the code, if it encounters disambiguation page, it also skips it. And it continues to save it, and actually it doesn't print while the articles are being saved, but it saved 9 articles to the database. And if we actually open the page, we saved 9 artificial intelligence related articles. Now we didn't really want 9. We wanted to limit it at 5. Maybe we can add additional instructions for it. So my new instructions are we only want to save 5 articles at a time. We also want to print the terminal when we are saving the articles. Now that I've written my instructions, I can come back to terminal and enter, and GPT-4 is going to reiterate our instructions. As you can see, limiting search results since only 5 articles saved should limit the number of processed search results. And it's actually adding feedback when saving articles. And Opus is going to take this into consideration and iterate on our code. So as you can see, we can actually use the user-guided mode to really improve our experience. You can set any iterations here to as many numbers, as high of a number as you like. But if it's user-guided, we set it to infinite, since we can continue until we don't want to. So here's our current code, which is now improved. Let's go ahead and run it. I'm going to go ahead and run the _2 file. And actually, let me delete the DB because it may have changed the DB's structure too. I'm not sure. I didn't take a look, but I'm just going to let it generate the database from scratch, just in case. And let's again ask for artificial intelligence, and let's open our DB. So now it skipped non-existing page. Okay, it did write saved articles, so it did save only 4 articles. and it did write whichever ones it has saved. Let's search for books again. Let's see. So it's not printing in real time. We can give it instructions, but it's actually printing after the fact. And it says that it has saved a total of 5 articles. Let's take a look at our database. And it has saved 5. I believe we can still give additional instructions. It tries to search 5 articles, and we can actually probably expand it so that it performs yet another search. But as you can see, I mean, this is a great way to write your query and let GPT-4 interpret it and instruct Opus this way. I will actually make another video or live stream, maybe exploring this in more detail. But the code files for this will be available at Patreon. I'll include examples as well. If you want to find out more about my videos, you can visit my website, echohive.live. And while you're there, you can check my other apps, such as AutoStreamer, which allows you to automatically create educational content, live stream it, and it also automatically builds a course website. For example, this is the one that I built.
Creating and using modules.
Teaching Python. You can actually visit this. This is deployed. I have a live stream showcasing it, and at the end of the live stream, I demonstrate how you can deploy it at Railway apps. Another one of my apps is CodeHive, which includes 900 plus free GPT-powered Python applications. You can do a real-time search, and the code for each app is available for free. You can just copy or download it. And if you do like the apps, you can actually download all 900 of them for $100 at my Patreon shop. I hope you enjoyed this. The requirements for this is very low, actually. Let's not forget to review the code as well. All you need is OpenAI, term color, and Anthropic. I keep going to cursor by accident, but yeah, requirements is pretty lightweight, and I am using the Claude Unified, which is just a class to perform simple and common tasks such as adding messages and clearing history and trimming history according to some length. And OpenAI Unified does the same thing. Like I said, if you want to find out in detail about those, you can actually watch my OpenAI Unified API video. And you can build your own classes as well in the way that you like them. So we do import the Cloud Chat and GPT calls, which just essentially is just a call to the APIs, but it just handles a lot of the stuff automatically, such as, like I said, trimming history, handling JSON mode, for example, for OpenAI, and also handling streaming responses. And we do give a file name here. I decided on working file, but you feel free to change that. And you do give a file extension, then this is, if you're working with an HTML file, make sure to change it. Then we combine them. The user guided mode can be true or false. And then we instantiate an Opus and GPT-4 instances from Cloud Chat. Both of them are going to have streaming true. We set the max history to 0. So we're not going to keep track of the message history, but we're going to be opening and checking the additional instructions and the last of each file, right? To see if you need to open, if you're working with an already existing file or not. If you wanted to start from complete scratch, right, make sure to delete these working files, whether HTML or .py, whatever you input here. This way you are actually starting a fresh project. But if you wanted to start from a file that you already have, then you can actually paste it here, working file.py here in this case, and the Opus and GPT-4 will take that into consideration. And we are using the Claude 3 Opus, but Sonnet and Haiku actually performs very well as well. Here we are setting a system message for Opus. You're my helpful coding assistant. Essentially, it's going to return the code in between these in the tags, so we can extract it. GPT-4 is instructed to do a review. So feel free to change this. I did say to review the code with a critical mindset, provide feedback, and suggest improvements to code both functionally, logically, and feature-wise. Try to catch any errors. And I did say always strive for best user experience and most beautiful code and design if visual elements are present, just in case if you're working with HTML, right? And I said only recommend up to 5 changes at a time. Feel free to experiment with these. When I didn't say recommend only up to 5 changes at a time, GPT-4 can recommend quite a lot, up to almost 10, maybe sometimes 15, too many changes at one time. If there are too many changes at one time, then Opus doesn't take them into consideration. Maybe even 5 is a lot. Maybe you may want to go with 3 or 4. But I'll let you decide on that. We have a function to open files, just a generic function. We are going to take an initial user input when we set our iterations, currently set to 3. If you do have user guided enabled, then we set the iterations to infinity. we initialize our n iterations and additional instructions to an empty string. Then we enter a loop. If we are in the first of iteration, and if it is user guided, we look for additional instructions if it exists. If it exists, we augment the user input, taking into consideration what you put into terminal plus the additional instructions, and then we clear the additional instructions. Perhaps you may want to make changes to this code. Maybe you want the additional instructions to always be there and not cleared, for example. Currently, this code doesn't do it, but maybe you can perpetuate, or you can add a persistence parameter. And if only persistence parameter is true, then you're clearing it, for example. I might actually try to improve on this code and make another video, and then we check for working file content. If it exists, we load it. If we have a working file content, meaning since this is the first iteration, that means we are actually going to work on a code that we already have. We want to open it and augment the user input. And also, I just added this line perhaps because if there's additional instructions, we are going to use augmented. But if we have a working file, we augment initial user input along with the contents of that file. But we also update the initial user input augmented with that. So that if we have additional instructions, then we use initial user input augmented. If you don't have it, then we're going to use just the initial user input. And then we just use the chat method of the Claude unified, which just adds the message and gets a response. To get an Opus response, and then we look for the code in between the code tags. Then we just simply write it to file and iterate on n. And if we check if we are user guided, then we say we print please provide additional instructions. We read the instructions, augment input, read the working file content, and then we send to GPT, review the code. This is the code. Please provide feedback such as improvements, original user instructions. If we have additional instructions, we use that. Otherwise, we just use the original user instructions just as a general guideline. And once we get the GPT-4 response, we make another call to Opus. We're working on this file. Here are the improvements you need to make. Make sure to apply all suggested improvements to the best of your abilities. We enter the GPT-4 response here as the feedback, and initial user instructions. We enter that. This is a general guideline. So this is originally what we were going for. Then again, we get the code out of the tags, and then we write them to file and initiate and iterate on the n. And if n reaches n iterations, then we break. So it's pretty simple. It's pretty loopy, but it's actually pretty simple. Works beautifully. I hope you'll make good use of it. Do let me know what you think, or if you suggest any improvements. Code files for it will be available at my Patreon. Link will be in the description, and I'll see you in the next video.